Final lesson, applying the normal distribution, day 3. So in this case, we're going to look at some of the stuff we did yesterday and then extend it to an interval situation. So recall, z-score table gives the area below a specific z value. It's a calculation of the area under the curve. Already done for you. You don't need to worry about it. You just got to find it in the table. How could you use z-score to determine the area for an interval? So what happens when you cut off both sides? Well, if you think about it, the area below B is the z-score value in the table for B. But that would go from B all the way to the end, and you don't want to go all the way to the end. You want to stop at A. So what you need to remove is everything after A. So really it's just the B value in the table minus the A value in the table will give you the interval. It's the easiest way to do it, and logically speaking, it kind of makes sense, right? B gives the z-scored B value goes all the way to the end, but you don't want to go to the end. You want to stop at A, so just remove everything that A does, because A is everything below. B minus A is going to give you the answer. So, ergonomics expert is analyzing the amount of time it takes to do a job in a factory. She finds data are normally distributed with a mean of 43.5 and a standard deviation of 4.5. What's the probability that any given job will take between 40 and 50 seconds? So, the mean is 43.5, the standard deviation is 4.5, and you have the two x's, 40 and 50, and you need to turn them into z-scores. So x, time a job takes, we got 40 and 50. Turn the 40 into a z-score, turn the 50 into a z-score. So 40 turned into a z-score, and 50 turned into a z-score. Now, the easy way to do it is turn the 50 z-score into a value in a percentage from the z-table, and then subtract the other z-score, the 40. So what that's saying is the probability from the table for your Z2 minus your Z1. You have to turn them into percents first, and then you do the subtraction. So make sure you do the percents before you do the subtraction. Don't subtract the z-scores. Subtract the percentages from the Z table. You get that through your z-scores. Let's try it again. Its probability a job will take 30 to 55. 30 with the same mean and standard deviation. 55, the same mean and standard deviation. Turn them into percentages. So find your percentages of your z-score. In this case, -3 is not on the z-score table. That means it's 0. If it's either 100% or 0. And if it's negative, it's 0 because it's going to the left. And if it's to the right 3, it's 100 because it's everything. 100%, 1.0. 0 is in 0. So in this case, 2.56 is 99.48%, minus 0 gives you 99.48%. On a cherry farm, 7% of the cherries are rejected due to small size. Assuming the mass of the cherry is normally distributed, mean of 6.71, standard deviation of 1.09. What's the mass? So in this case, you have a percent, 7% of the cherries. Go to your Z table, find 7%. Turn that into a Z-score, and you're just basically working backwards. So you have the percent, turn it into a z-score. So 0.07% turns into a z-score. Once you have the z-score, then you can use the z-score formula to find x. So from the table, 7% is negative 1.48. That's the z-score. You know the z-score formula, so put it into the formula. Now solve for x. So intervals and working backwards, the two new things from today.